What's going on, guys? In this video we are going to see how to find unknown currents using mesh analysis by inspection method. Now in order to do this method we have to follow all these 4 steps. The first step is assign mesh currents. We already assigned it. This is I1, this is I2, I3, I4, I5. Now the next step is find resistance matrix elements. Now let's go ahead and find the diagonal elements first, and then we can find the shared elements. So first diagonal elements is going to be R11. So in this case what we have to look is we have to look at the mesh one and see what are the resistance in this mesh one. And we have 4 ohm right here, 1 ohm right here, also 3 ohm. So we have to add them together. This is going to be 4 plus 1 plus 3, and that's going to give us 5 plus 3, that's going to be 8. And R22, so it's going to go until 5. Since we have 5 meshes, it's going to go like R11, R22, R33, and it's going to go until R55. Now R22, what we have to look is we have to look at the resistances in the second mesh. In the second mesh we have 3 ohm, 1 ohm, and that's it. These are the 2 resistance we have, so we have to add these 2 together, and this is going to give us 3 plus 1, and that's equal to 4. And the third mesh we have, in the third mesh we have 3 ohm, 2 ohm, 4 ohm. So this is going to be 3 plus 2 plus 4, and that's going to give us 3 plus 2 5, 5 plus 4 9. And in the fourth mesh we have 1 ohm, 4 ohm, 1 ohm, 2 ohm. So this is going to be 1 plus 1 plus 4 plus 2, and also we have one more 2. So this is going to be plus 2 again. So 2 plus 2 is going to be 4, 4 plus 4 8, 8 plus 2, that's going to be 10. So this is going to give us 10. And R55, in the fifth mesh we have 2 ohm, 2 ohm, 5 ohm. So this is going to be 2 plus 2 plus 5, so that's going to give us 9. Now we have the diagonal elements. Now the next step is we have to find the resistances that is shared. Now in order to do this one, since we have a lot of them, we can go with this order. Like if you put R12, we can go like R12, R13, R14, R15, and then R21. So we can go like this, right? So let's go ahead and let's begin with R12. In the R12 is going to be equal to R21. Now we have to look at the resistance that is shared in the first mesh and the second mesh. So 3 ohm is shared in the first mesh and second mesh, right? That's common for both. So that's the value we are going to put right here. And also we have to put a negative for the shared resistance. And then we go to R13, and R13 also R31. So R13 is the resistance that is shared with 1 and 3. We don't have any of them because we have 3 is in this side and we have 1 this side, so we don't have any resistance that's connected with these 2, so this is going to be just 0. Then R14, that's going to be R41. So we have to look at 1 and 4. We have 1 ohm is common for each of them, so we put minus 1. And then R15, R51. In R5 is right here, 1 is right here, so we don't have anything that is shared, so this is also going to be 0. Then we go to the 2. Since we have only 5 meshes, we don't have anything, like we don't have R16 because we have only 5. Then we go to the R21. R21, we already got the R21, right? Because R12, R21, it's equal, so we don't have to do that. So let's go to R22. R22, that's a diagonal element, and then we have to go to R23. We don't have this one right here, so we can put it. R23 is going to be equal to R32. R23, we have to look at the resistance that's shared with 2 and 3. We don't have anything, so this is also going to be 0. Then R24, we don't have that one before, so R24, R42, 2 and 4 has 1 common, right? This 1 ohm is common, so that's going to be right here -1. And then R25 and R52, 2 is here, 5 is there, we don't have anything common, so this is also going to be 0. Now after that we have to move to the 3 because 5 is the last one, right? And then R31, do we have that one already? We have that one right here, so we have to go to R32, that's also we found out already. And then R33, that is diagonal element. R34 we can find, let's see, R34, R43, 3, 3 and 4 has this 4 ohm common, so this is the one we are going to put -4. And then R35 is R53, and 5 and 3 has this 2 ohm common, so this is the one we are going to put right here. And the next one is going to be so 5 is the last. Then let's go to R4. R41 we have, R42 we have right here, R43 we found out, R44 is diagonal element, R45, and R54 is going to be, so R45 is what, 4 and 5 has this 2 ohm common, so we can put that one -2. And this is going to be the last one, we don't have anything else, right? And that's it. After we found out these things, we have to put a diagonal, we have to create a matrix. You know what, I should have moved this one to this side. Let's copy this one in this side, so we have space right here, right? So R34 is equal to R43, that is -4, R35, R53 is equal to -2, and R45 is equal to R54 is equal to -2. Now let's erase this one. Now we can create our matrix. Okay, so here we are going to have 5 by 5 matrix. Let's put these diagonal elements first. So 1 1 1 2 2, so this represent first row first column, second row second column, third row third column, fourth row fourth column, fifth row fifth column. So it's going to be a diagonal like this. So this is the first value is 8, 4, and then we have 9, then we have 10, the last one is 9. And first row second column we have -3, and second row first column also we have -3. First row third column we have 0, and third row first column we have 0, and we have first row fourth column we have -1, and fourth row first column we have -1. Then we have first row fifth column we have 0, and fifth row first column we have 0, and then we have second row third column we have 0, second row third column, second row third column we have 0, then third row second column also we have 0, then we have second row fourth column -1, and fourth row second column -1, and second row fifth column 0, fifth row second column 0, and then we have this one, third row fourth column -4, fourth row third column -4, third row fifth column -2, third row fifth column -2, third row fifth third row, fifth column should be this one, right? Third row, fifth column, -2. Fifth row, third column is -2. And then fourth row, fifth column, -2. And fifth row, fourth column, -2, right? So this is our matrix. So now after this, what we have to do is I1, we are going to have 5 currents, I1, I2, because 5 meshes, right? I1, I2, I3, I4, I5, and in the other side of this equation we have to put the voltages. Now what we have to look right here is we have to look at our voltage source, and we have to look at mesh currents, and we have to see mesh current is going through which one. Like if it's go from minus to plus, that's going to be a voltage rise, so it's going to be a positive value. And if it's go from plus to minus, that's going to be a voltage drop, voltage drop, so that's going to be a negative value. Now let's look at I1. In the I1 mesh, we don't have any voltage source, so we put 0, right? And the second one, in the second mesh we have this voltage source, and I2 is going from plus to minus, right? This is the direction, and plus to minus, that's going to be voltage drop, so voltage drop is going to be -6. And third mesh, we have this voltage source, also this voltage source, so here it's going from plus to minus, that's going to be -12, and here it's going from minus to plus, so that's going to be +6 voltage rise, so it's going to be +6. So -12 plus 6, that's going to give us -6. And then we have I4, we have this voltage source, also this voltage source. This voltage source is going from negative to positive, +10. This voltage source is going from plus to minus, voltage drop, so that's going to be -4, +10, -4, +6, right? +10 -4, that's going to give us +6. And fifth mesh, we have this voltage source, so this is going from minus to plus, so that's going to be a positive number because voltage rise, and this is going to be +4. And this is our matrix. Now to find I1, I2, I3, I4, I5, we have to use Cramer's rule, but since we have 5 by 5 matrix, it's really hard to do it by hand, so you have to use a software, or you can find Cramer's rules calculator online. So if you plug the values, that's going to give you the answer, right? And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.